great that you want to present your European work on digital twin development.
Yeah.
Please go ahead.
So many links that other presentations are making to DigiShape, I think we have to do after the presentation because it's my first time in this context. I'm Felix Dols, I work for Deltares and will present the work of a big consortium which is working on the European digital twin of the ocean. There are two projects. One of them is the Edito Model Lab, so creating the model layer, and the other one is on infra, creating the platform. On the Edito Model Lab project, we work with Italians, French, Spanish, Portuguese, Norwegian, Danish, German, and Dutch institutes. But on the platform side or the Edito infra side, also, for example, FLIS, who has the responsibility for the AMODnet platform, is also included. There's a couple of steps that we want to make in this 3-year project. So the European Commission's goal is to make ocean knowledge accessible for a larger amount of stakeholders and users. What we're doing as institutes here listed is we prepare the next generation of marine models, so we continuously improve our simulation software on multiple levels. We want to integrate the system in existing infrastructure, so computing infrastructure and data infrastructure, and we want to demonstrate the capabilities, and then supposedly stakeholders become knowledge partners, and this is also about the user interface. So there's many developments that we're doing for the models. I will just highlight one because we have 10 minutes. So this is one working on myself to include artificial intelligence to replace part of our physical-based numerical modeling. So to speed up simulation time. So if we want stakeholders who are not modelers to interact with our models, we want to speed up the model, because otherwise you send it to a high-performance computer and you get an answer days later. So components of our model, in this case the predicting of suspended particle matter, so the amount of sediments and organic matter that is suspended in the water, to predict this by a statistical method, so by artificial intelligence, and this will save some computational time, and this is important for any kind of ecological modeling. We will do this in the Wadden because it's a quite a complex area to do this kind of prediction, and it's already a proven method from our French partner in the Gulf of Biscay, or the Atlantic Ocean side of France. And this reminds me a little bit of the Stapel model that Sibren explained, but maybe a bit more fancy representation. We will stack a system on infrastructure and on a data lake. So in the data lake, for example, AMODnet and the Copernicus Marine Ecosystem Services, they are already integrated in this lake. But I would be happy to add more and more sources and to connect to more and more platforms. On our platform, any institute, and firstly we ourselves, we put a service and we can propose new data, but it would be nice if more and more institutes or organizations will pick this up. And here's a list of some of the projects where we already are connected to. And for the engine, we connect to high-performance computing resources, for example, in Spain and in Italy, but also we want to do this with SURF, but no such plans are concrete yet. So to demonstrate some of the capabilities, because we talk about modeling, many different models can do many different things. We promise to focus on a couple of issues. So we ourselves, together with a German partner, we work on habitat suitability modeling, so to show in an area where habitats are feasible to exist or to grow, which is good information for managing, for example, a marine protected area like the Wadden Sea. CMCC, so an Italian partner, is using ocean data for cost efficient or fuel cost efficient ship routing in the Mediterranean Sea and in the ocean, and so to use wave and wind data and current ocean currents to plan your routes to save fuel. And we work on simulation of plastic distribution and transport to retrace also back to the source and to design for preventive measures. We work on nature-based solutions, so to model with an ensemble of thousands of different models what the impact would be for seagrass meadows before the coast, for coastal erosion prevention or coastal safety. Another scenario on marine plastics, and what I will go into a bit deeper is something that we're also doing at Deltares. So in our hydrodynamic model, we also include the growth of organisms. Also because now in the blue economy there's many plans for multi-use of areas where we are already harvesting wind energy to also cultivate, for example, shellfish in nets to promote the growth of shellfish. And now we're adding another process to this dynamic energy budgeting, so that also the shell of the shellfish is modeled, which doesn't give us any extra information on the volume of shellfish that is growing, but it does give a more complete modeling of what happens to the carbon cycle. So the organism respirates, so it's a carbon source, but in the making of a shell there is also carbon capture. So in the end we want to be able to say what is the impact on the carbon cycle if we promote in this area the growth of shellfish. And so this is about a sustainable growth for the blue economy. So one of the applications that we where we demonstrate the power of this platform with. For the user interface, already there's a couple of different layers. So to interact with the data from EMODNet and from CMEMS, we work with more fancy viewers like this. To interact with our models, we work with a bit less fancy viewers. This is already accessible, where we want users to be able to draw a bounding box, and now only rectangulars. Then there's a catalog of different data sets that is represented in the bottom of this page, where you can see, okay, in this area what kind of data is available, and where we in our project are now adding also relocatable models from. So from this data we get the boundary and the initial conditions and the forcing to set up a model quickly. This is a rough model, so if you want a better model, for example in the North Sea, for decades already we've been improving our model. So this is just for on-demand, like first estimates modeling, which we want to make accessible. Another side of this platform is that we're now publishing services, so which are currently already open source from different institutes. On this platform we want to publish it for others to work with that. So for example, we are now working on getting our Deltares, so our hydrodynamic model with water quality components on there, and ecological impact assessment tool, where users with a Jupyter notebook, so first for more intermediate or technical users to interact with this code and also to run it on this platform. So the platform is connected, as when we saw the globe, is connected to computing resources, both on the cloud and high performance computers for more heavy simulations. And it's connected to AMODnet and to Copernicus data, and hopefully also in the future more. If you look at the left, you can also add own data, and if you publish it, you can say, okay, I want to contribute this data to the data lake. If you want more information, you can follow us, and the site that I just showed is on the bottom, where it's in beta version, so not a lot can be done yet, but at least you can have a first view on what we're proposing. But that will be about it. Hopefully it was in time.
Oh, exactly in time. So, thank you very much. Thanks, Felix, to give us the international context, and we will focus on the Dutch context soon. Questions?
Yes.
Of course. Okay, we don't know each other. I'm Deltares from Maris. We do a lot in EMODnet, uCloud.
Yeah.
And I just want to make a statement here. It's not really a question, but what you see, these sort of initiatives, they're really data hungry. You really need data lakes and not just files coming to you, but you would need to have exactly that data in the area that you want to run the model.
Yeah.
And then your model and your product gets better. And I want to remind us of the arrow that Wim pointed out missing. Because if you want to do it well, you need also regionally the right data. And these sort of European initiatives, they drive on the data being available from all these data centers. So that is really something we have to focus on in the Netherlands, to make sure that our data is in a fair way, it's findable, accessible, interoperable, and reusable. Because what you're doing is the reusability.
Yeah.
You're reusing already collected data.
Yeah. And in our demonstrators, we use, we zoom into areas where we know we have data ready, right, from previous projects.
If you're not knowing it, you don't know if the data is there and if it's the right quality that you need. So, I think we have way more data than is now in EMODnet. We have way more data in the Netherlands than is available.
For sure.
Did you run into it? That's nice. Did you run into it already when you're scanning? Did you really have to look well?
So for all the applications or the demonstrations that we're proposing, everyone is delivering own data. So still all institutes are using their own data or adding contributing data to it, but it would be nice if that is stored and also in this catalog easily traceable. Then you can see, okay, actually there is something for this area that we can work with, and we still have to also to make model simulations available for people who are not technical, for more stakeholders. We need to communicate well, okay, these are the uncertainties, and when there's a lack of data, the uncertainties will be very big, because we have no possibility to validate our model.
Really nice, thank you. Johan?
I have a question. How are those websites maintained, and by whom for the long term?
Yeah, so for our partner in Toulouse, Mercator Ocean International, they are now also maintaining the marine ecosystem services from Copernicus. And like EMODnet, they have like a 7-year contract with the European Commission to maintain the data platform, and also for this digital twin ocean platform, which would be staggered on top. We hope that after the project, a service contract like this will be the case, and we already see that the European Commission is like asking for new projects starting in 24, 25. So a platform will be needed for other projects as well. So we think something like a service contract will be tendered for.
It's turning into a program more than a project, project. So it's really something they put their money on now. They're investing millions in it. So
One last question.
Could you please elaborate a bit more about the artificial intelligence you were explaining? It means that you first feed your model with a huge amount of scenarios, either dynamic scenarios, and then it trains, and then based on the prediction or whatever climatology data, it will give it will predict this hydrodynamic without running